Okay. Does this work? Yes, I guess so. Um, so I am Andrea Barillari. I work for Warner Bros. Games, and this is the second time I speak here. Really, I would like to thank Franco. Uh, I would like to thank Franco to invite me for a second time. And in case anybody from WB see the video on YouTube, um, I have to say that I'm here not representing by any means WB. I'm here representing myself, and that's it. So I I didn't prepare a an introduction slide like last year. Great. But I can say that I worked on several titles with WB. I worked on Gotham Knights, Suicide Squad killed the Justice League, and Mortal Kombat 1. And all these three games have one thing in common: they use Unreal. So even though I am a UI programmer, I make user interface. Um, I had to deal a lot with the garbage collector in Unreal. And so I thought this talk could be useful for anybody that works with Unreal, and specifically any programmers, because it doesn't matter if you are a gameplay programmer, a UI programmer, an AI programmer, you will eventually have to deal with the GC. And the GC, even though it's created for helping you as a developer and managing memory, can be the cause of a lot of bugs. So why we may want to have a GC in a game engine? First of all, memory management, because memory management is hard, and a GC makes your life better, your life as a developer. It should prevent memory leaks, even though the GC, it is totally possible to have memory leaks in Unreal using the GC. We'll see that in a moment. And also, GC helps you helps you supporting scripting languages, such as the blueprint scripting in Unreal. It won't be possible without the GC. Of course, there are a lot of cons of using a GC inside a game engine. One of the reasons we use C++ in game development is because C++ is fast and it doesn't have a garbage collector as a standard solution for memory management. And so not every game engine has a garbage collector. However, the team at Epic chose to have a GC, and this brings some issues, of course. So performance overhead, GC is expensive. In the CPU. It can be a huge bottleneck, causing frame hitches and even bugs if you don't know what are you doing. It increases your memory's usage because, of course, the GC needs to have more data structs in order to work. And I have already said that, but of course, there are potential. You can create bugs if you don't know how this GC works. And so let's jump and see how the GC works in a real engine. So first of all, UE keeps track of every U object. I'm taking some UE knowledge for granted. I'm sorry. So UE keeps track of every U object instances allocated in the heap. And so the GC really works inside the U object domain. For everything that is not a U object, you will have to deal with memory by yourself, either using a share pointers or some other techniques. I have highlighted in yellow in these slides some function names or variable names that are used in the engine in case in the future you want to take a look at the code. So the FU object array is the array that contains all the objects that are allocated during the course of your game. Some UObject instances are flagged as root, and those root objects are not gonna be garbage collected as long as they are part of the root set. And the root set is a really important part of how the GC works. We are gonna see it in a minute. Some classes that are part of the root set are the UWord, UGame, Viewport Client, and UEngine. And when the GC starts his pass, so it acquires a lock ensuring that nobody else performs operation on UObjects, such as creating new UObjects. So if you try to create a new object while the GC is running, your action will be frozen until the GC is done with its job. So after the lock is acquired, the GC performs a reachability analysis to see what objects are still needed and they have to stay in memory, and what instead can be purged. All UObject instances are flagged as maybe unreachable, and then also all the clusters and objects in the root set are marked as reachable. I'm going to talk about clusters later when we are going to talk about optimizations. And so once we have that, the GC collects all the referenced objects and flags them as reachable. We're going to see how how objects can be flagged as reachable in a minute. And then all objects still flagged as maybe unreachable will become unreachable. And so the GC knows at this point what objects it needs to destroy. And so it frees the lock, and all the unreachable objects are purged and destroyed. And every pointers that you have in memory that are purged are going to be set to null. So how the references are collected. So there are 4 main techniques. So we already talked about the root set. So objects in the root set are not going to be garbage collected. They are going to be flagged as reachable always at every GC pass. Starting from the root set, the GC, thanks to the Unreal reflection system, is gonna see which variables at every instances are stored as U property. And so starting from the root, the GC creates basically a tree, actually multiple trees starting from each root node. And every object that is reachable in this tree is flagged as reachable. If you know Unreal, you know that you can use U property only inside UObject classes. So there are some cases where you have a U object and you need to keep it in memory, but you don't have a U object owner. And so there are other 2 techniques, the last 2 that you see in the slide. that helps you retain a strong reference to that object, so that that object is not destroyed. So first one is T strong object pointer. This works like a smart pointer, but for U objects. And so once the owner object is goes out of scope, any strong object pointers are going to be destroyed. You have to pay attention that you don't create a reference cycle between the owner and the pointer inside the T strong object, because if you do that, they will stay in memory forever. And for the last method is the FGC object, which is basically an abstract class in C++ or an interface. Basically, there is a virtual method that you can override, and you can specify a collection of objects that you would like that object to retain. Once that object is destroyed, all the object that you specify in that method will be eventually purged. Of course, for the last two methods, you will have to take care of the memory by yourself of the owner object. So, about GC references. Whenever you create a new UObject instance, you have to make sure that this new instance is referenced using one of the methods that we saw in the previous slide. If a newly created object is not referenced, it's going to be destroyed at the next GC pass. So if you store the memory address of that object and you didn't reference it by any meaning, so you, for example, you didn't put that variable inside a U property, that object will be destroyed by the GC at its next pass. So if you try to access that variable, you're gonna get undefined behavior. So very likely you're gonna crash your game. You can use T-weak object pointer whenever you don't want to a specific class to have ownership on a object instance. And I highly recommend to avoid using row pointers. That brings chaos and pain, trust me. T-weak object pointer are also useful in lambdas for asynchronous or multi-threaded code. So instead of passing row pointers, you should wrap your object pointers to a T-weak object pointer and check if it's still live once you use it inside the lambda. Unlike some discussion that I found online, the outer property does not count as a reference. So when you create a new object, you pass the outer, even if the outer is referenced by some other variables, that won't count as a reference by the new object that you have just created. So it's really important that you put it inside a variable that is flagged as uProperty. And the uProperty method is the method that I recommend to use like 90% of the time. And of course, there is no need to worry for actors or object created in Blueprint Graph. So this is why this talk is mainly for programmers. About the root set. When you add an object to the root set, you have to remember to remove it from the root set whenever you don't need that object anymore. If a root object goes out of scope and you didn't remove it from the root set, well, you just created a memory leak. So by using the GC that is supposed to avoid memory leaks, you can create actual memory leaks. So I don't recommend to add manually objects inside the root set by yourself. Just let the engine do that and forget about this technique. If you want an object to be destroyed, one thing that you can do is put that variable, the pointer to null, and eventually, if there is no other references, that object will be destroyed. But you can force an object to be destroyed, not immediately, but at the next GC pass, even if that object has multiple references. You can flag it or mark it as garbage. So that is the console command to enable this feature. And this happens when you explicitly destroy, for example, an actor or actor component in Unreal. And please do not call conditionally begin destroy as somebody suggests on the internet. That can cause, again, pain and troubles. When an object is marked as garbage, it's not evaluated during the reachability pass, and it will stay as unreachable. So it will be destroyed no matter what. And when an object is marked as garbage, when the GC pass and the GC pass hasn't happened yet, the memory address will be still valid. However, the object shouldn't be used at all. So I recommend to use the isValid method instead of checking explicitly if the object is null pointer, because it won't be null pointer, but it will be destroyed very, very soon. Okay, let's talk about some optimizations that you can do on the UE GC. The first one is really simple. It is enabled by default. You can allow the GC to run in parallels, so on multiple threads. Specifically, the reachability analysis that we saw before will run on multiple threads, and the GC will try to use every core that the hardware provides. Another optimization you can turn on is incremental purge objects. So by default, the GC tries to run, the GC runs, do everything that it can in one single frame. So this can cause huge frame spikes. So with incremental, several works can be broken down into multiple frames. You can break down the purge step. So, and you can do it by turning on the incremental begin destroy, and you can set the time budget for the destroying object phase, specified in seconds. So by default, you have 2 milliseconds. But that, of course, can be tuned depending on your game needs. And in UE5, Epic introduced the possibility to have the reachabilities analysis in incremental mode. So the steps that we saw before, where each object is first marked as unreachable, then to reachable, and then again to unreachable, can be done in multiple frames. It is experimental, so Epic doesn't suggest to ship a game with this feature turned on. And you can see the comments that enable that feature. As the previous step, you can set a time limit for the incremental reachability analysis. Another optimization you can do is to have clusters. So instead of working on single objects, you can group several objects into clusters. So the GC will treat all these object groups together as one. And this will speed a lot the reachability analysis step. The create GC cluster feature is enabled by default, but it won't do nothing if you don't enable one of the two other things that you see on the slide. So I said two things. I mean, one thing, the other is on the other slide, sorry. So the first of the two is actor clustering. So it works with U levels. If you know a reel, you have levels and you can stream levels, and each level can have actors in it. I mean, static actors or skeletal or dynamic actors that are that populates the level when you streaming it in and present it to the player. And the level and all the actors referenced by this level itself is going to be treated as cluster if you enable this particular type of optimization. And you can control which actors can be in clusters by toggling that variable there, B can be in cluster. But there is also asset clustering. It works with assets that can be cluster roots. And every object, just like before, every object that is referenced by the cluster roots will be grouped together and treated as a single object. There are few types that can be treated as cluster roots. You have the Niagara or particle systems. So whenever you spawn a new collection of particles, you can have all the particle object treated as one single object. You have blueprints. So blueprints can be cluster roots. So anything that a blueprint instance references inside of itself can be grouped into one single cluster, with the exception of level blueprints. You have sound cues, and if you know sound cues are a collection of several sounds. And then you have material, because in a reel, a material can have multiple material functions. And then so you can have a single material composed by multiple materials. And so even this thing can be treated as a single object. And you can enable it with asset clustering enabled. There is an actual typo in the Unreal code. And so clustering should improve reachability performance in general. But keep in mind that there is a memory overhead, because once you use clusters, the engine will have to store those data inside structs and several data types. So you will use eventually more memory. And if you have objects with different lifetime that are grouped together, you can get little or no advantages from clustering, because you are keeping in memory multiple objects when they could be freed from memory because they are not needed anymore. Another optimization is the GC disregard. So it is possible to flag some objects to be excluded from the GC evaluation. So the GC will skip those objects totally. You can control which objects can be excluded from the GC evaluation by calling those two methods. So you call the first method, then you allocate as many objects you want, and then you call the second method. All the objects that you created in the middle, they will be excluded from the GC evaluation. So they will stay in memory, but they won't impact the GC performance. The GC performances. Um, that is the command so that you can control how many objects can be considered by the GC disregard. If you put that to 1 or 0, it means that basically it is disabled. And by default, when GC disregard is enabled, UE excludes automatically all the objects allocated during the F engine loop pre-init, which is a procedure that runs when you start your game. So a lot of objects that will stay in memory anyway, because they will be needed through all the course of your game, will be excluded from the GC evaluation. So it is a good optimization that you can use. So I think I have one more slide about optimizations. So of course, wait, no, 2 more slides. You should keep your UObject budget in check. Of course, this is not always possible because from what I saw working in AAA games, when you have games like in open world, but even a fighting game like Mortal Kombat, and when you enter inside a match, you have millions of objects allocated. So the GC can really impact your performances. But anyway, you can control the UObject budget a bit by not making every class in your game derived from UObject. Also because UObject is really heavy. It has replication feature, it has reflection, it has automatic memory management, so the GC, and sometimes you don't want all of that inside a class, so you can just create a normal C++ class and you are good with it. Another way to keep your UObject budget in check is to use object pools. So if you know what is an object pool is basically a container where you store 2 different array of objects. One contains the objects that are currently in use, and one contains objects that are no longer used but can be reused in the future. For example, I am a UI programmer, so I have to deal with this a lot. Unreal provides the F user widget pool, a struct that automatically implements a object pool for UMG widgets, and you can use that in a lot of ways. Think about having your player opening a menu multiple times in a very short span of time. So if you do that, you are going to allocate thousands and thousands and thousands of objects. And eventually, when the GC runs, you will have all these objects that are no longer used because every batch was menu opening. So you're going to get, for sure, a huge frame spike. So you have 2 solutions. One is caching all the objects that you create, and the second one is actually using the F user widget pool. So you can also control in Unreal how frequently the GC runs, and this is awesome because other engines like Unity doesn't give you any control on that. So by default, the GC runs every 60 seconds, but you can toggle that time. You can tweak that time frame. You can have a secondary time frame when your game is running on low memory. So when your game is running on low memory, usually you want to run the GC more often, and you have those two console variables that you can tweak. And also, there is a tertiary level of GC running time frame, which is when you are basically unloading memory, unloading levels from memory, and usually this tertiary time frame should be the lowest possible. You can also force the GC to run. You don't have to wait for the GC to happen. If you know you are in a spot where a frame hitch or frame spike is acceptable for the player, such as a loading screen or a fade transition, a lot of games do that. When you see a game that fades to black, and that game is made with Unreal, there is a huge chance that the GC will run in that particular moment. You have two methods that you can do that. You have try collect garbage, so it will perform the GC if no other threads have a GC lock, or you can just call collect garbage, and it will eventually run the garbage collector anyway. And there is a third method that you can use to optimize the GC, which is actually turn it off. And I don't recommend it unless your game is very small, you know what you're doing, and maybe you're running on a very limited CPU hardware, like a very old Android mobile phone. There is no way to do that, out of the box. But you can go to uEngine and just comment the conditional collect garbage call. Again, I don't recommend to do that. I'm actually done. It was really, really quick. Question time.